Hello students, welcome back to my channel again. Today we are going to learn class 12's probability chapters. The topic random variables and its probability distribution. And this is the 9th session of the chapter probability. So let's start with the video. Now before we go to this particular topic, I just want to share with you some examples. You all know that when we make an experiment, suppose a coin is tossed, tossing a coin, then normally what we have seen that how many outcomes are there and which are they, like head and tail. Then suppose throwing a die. Okay. So what we have seen suppose means 1, 2, 3, 4, 5, 6. These are the outcomes, and we have seen another thing that we have found how many suppose odd numbers and even numbers, multiple of 3. So like that means there are many things you can assume, but we suppose there are some of the experiments like tossing a coin twice. Okay, I'm taking twice, you can take more than 2 times. The same concept will be there. So it's HH, HT, TH and TT. Now, normally we have done that the events of suppose getting exactly two heads, or suppose head is means only one head, or at most two heads, and about tails also, many things. Here we will not be looking at those particular events, rather we will be looking at these outcomes in different way, and we will be actually means representing these outcomes in some real number. How? Suppose I'm telling that you have to find out number of heads. Okay, in all outcomes, what it will be? For HH, this is 2. For HT, this is 1. For TH, this is 1. And for TT, it's 0. So ultimately, what we have got, 0, 1 and 2. So these are 3 values which are connected to all outcomes of that particular sample space. Now, this number of heads, this description belongs to each and every outcome. Therefore, this number of heads is a variable which can take the values either 0 or 1 or 2 and related to all outcomes. These type of variables is called random variables. Okay, so let us give you some more examples, then this particular topic will be little bit more clearer to you. Now let us take an experiment. Suppose throwing a die twice. What will be the sample space? Sample space will be, You all know 1 comma 1, 1 comma 2, like 1 comma 6, and then dot 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 dot, ultimately up to 6 comma 6. Here 36 elements. Now, if we suppose assign a rule like number of heads means what? We are not fixing up number of heads here for this first experiment. Rather, we are assigning a rule to all the outcomes, that is number of heads. Okay, here also suppose we are going to find sum of two trials. Okay, we are not fixing the sum of two trials is 5, sum of two trials is 7. If we are fixing it up, then it will be again the same particular number, particular sample points. But we need to get values that can vary. So then it will be a variable. So sum of two trials. In this way, what we can get? We can get 1 plus 1 equals to 2. 1 plus 2 equals to 3. Again, 2 plus 1 also equals to 3. So 3 is gone. Now for 4. 1 plus 3, 3 plus 1, and 2 plus 2, 4. Okay. So for 2, there is only one outcome. For 3, there are two outcomes. For 4, there are three outcomes. Like this, we will be getting up to maximum sum, that is 12. 6 plus 6, not more than that. So we are getting all possible numbers starting from 2 to 12 for this particular description or the rule. So what we can say? We can say that this rule varies its values from one outcome to all outcomes. That means this is a variable, and this variable is called a random variable. Okay. Now random variables general notation is capital X in capital letters. Random variables general notation always will be written in capital letter. It could be written as capital X, capital Y, like this. Okay. Now random variable, if you are looking at random variable, this X is a description, suppose, like this. Okay. It is operating or ruling on the sample space and giving us some particular values or a set of values, like this. Now you go back to the conception of the function. So X is quite like a function where X operating on sample space, and then from sample space we are getting the final value sets. Suppose this is M. That means X is a real valued function whose domain is sample space and the range is this, the set M. So X means the random variable is a real valued function. Okay. I hope now you have understood what is random variable and how we are taking it. Now, before going to the next topic or next definition, I will be sharing with you some examples on random variable. So let us construct an example. Suppose we are tossing a coin thrice. So we know its sample space, that is S equals to H, 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 T, H, T, H, T, so T, H, H, then H, H, T, then T, H, T, 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 H, H, T, T, and T, T, T. So there are 8 elements. Now suppose we are assigning a variable which denotes the gaining amount and gain or loss by a person. Okay, gain means for each head the person gains ₹2, and for each tail the person lost ₹1.50. Therefore we can get like this: x of h means 3 heads are there, so there is no other sample point which have 3 heads. So this is equals to gaining amount, that is 2 into 3 equals to ₹6. Okay. Now x of HTH equals to x of THH equals to x of HHT. All 3 sample points are having 2 heads and 1 tail. 2 heads and 1 tail. 2 heads and 1 tail. So ultimately their amount will be equal. So that is 2 into 2 for winning amount plus, this will be 2 into 2 for winning amount and losing amount for 1 tail, that is minus 1.50. So ultimately it's coming positive, that means of winning amount, that is 4 minus 1.50. So it is coming ₹2.50. Now we are taking the variable x on the sample points having 2 tails and 1 head. So there will be 3 members: HTT, here it is, TTH and THT. For this we will be getting ₹2 for 1 head, 2 into 1, and losing amount for 2 tails, 2 into 1.50. Ultimately it's becoming 2 minus 3, so minus ₹1. This minus represents the losing part. Okay, then what is left? Left is, that is having 3 tails, and this is only about losing something, so minus ₹1 into 3 into 1.50. We are getting minus ₹4.50. So for all 8 sample points we have found the particular assigned rules values. So ultimately we are getting the values of this particular random variable related to or associated to all sample points of this sample space. It's becoming like minus ₹1, and then ₹2.50, then means minus rupees 4.50 and rupees 6. This minus sign represents the amount what is lost by that person. Okay, so this is the type of question that you can get, and the question may be like prove that x is a random variable. So you can see that x is obviously a random variable because x can be associated to all particular sample points of a sample space. Okay, and suppose it exhibit it as a function on the sample space of the experiment. So yes, x is varies from, suppose this is the range set, so R, so x is varies from sample space S to the set R. So x is a real valued function. So students, this is all about today's session, and that is about random variable. And in the next session we will be doing random variables probability distribution. Okay, I hope you have understood the concept of random variable. So till then, bye bye and thank you.